This is worksheet 5.5D. We're going to be talking about vertical translation of exponential of equations. Okay, so what were the instructions are telling us? To write the new function and write a short explanation on how the graphs g of x and h of x change from f of x. So the idea is here, we are given an exponential function or an exponential equation, and we're given the graph to that exponential function. Okay, then we're given two other graphs, g of x and h of x, and these graphs, although it's hard to tell because the graphs are shifted differently, these two graphs are identical to this graph. Okay, so because they're identical, what that tells me is that the equation 2 to the x power for each graph is going to be exactly the same. Okay, so that part's not going to change, but logically something has to change in the equation because something changed in this graph. Okay, and if you notice, what changed in the graph from the g of x graph to the f of x graph is that the graph, it's the same exact equation except for it was shifted from having a y-intercept of +1 here to having a y-intercept of +4 right here. Okay, now that is very important because this equation, if I thought of it as 2 to the x power plus 0, you will notice that the y-intercept is 1 more than that value right there. So that means if the y-intercept to this graph was +4, we can see 1, 2, 3, 4, that means the number that tells me how to shift this was 1, this number is going to be 1 smaller than that. So that would be +3. Notice here we had a +0, my y-intercept was +1. That was 1 more than that. Here we have a +3, my y-intercept was +4. So we put a +3. Okay, same idea with h of x, except for we could see h of x's y-intercept is at -2. Okay, and the graph was shifted down in respects to the very first graph that I was given. So since the graph was shifted down, I'm going to put a minus sign or a subtraction sign after my exponential function, and then it went down 2. But I don't write -2 here. Remember, the idea is the number that I write is always 1 smaller than the actual y-intercept. So the y-intercept is at -2. 1 smaller than that is -3. So the equation would be h of x is equal to 2 to the x power -3. Okay, in number 2, we're doing the same idea. We're given a graph. F of x is equal to 2 to the x power, and notice once again this graph has a y-intercept of +1, and I can think of this as 2 to the x power plus 0. That number there always tells me how to shift my graph. That number and where the graph, how many spots the graph is shifted up and down the graph on the y-axis is always 1 below its y-intercept. So on the g of x equation, you can see we have the graph. It's the same graph as this one. It doesn't look like it, but it is. But its y-intercept is +3. So that means I'm going to have the same exact equation, 2 to the x power, but then I'm going to put plus, and I don't put +3, I put 1 below it, so that would be +2. The y-intercept of the graph is always 1 higher than the value that we add or subtract. Okay, the last one, it's the same exact graph, so it's going to have the same exact exponential equation aspect of it, which is 2 to the x, but now you can see that the graph was moved so it has a y-intercept of -3. So that means I have to put a number here. Well, it's below the x-axis or 0 on the y, so I know it's going to be a minus, and then I don't put the number where the y-intercept is, I put the number 1 below that, which would be -4. So my equation for this graph would be h of x is equal to the x power minus 4.